Good day everyone, here's our math challenge for today. And here's our question. So given these two semicircles, wherein the diameter of the big semicircle is cut into three segments, we have 2, 4, and 5. And our goal is to find the area of the region shaded in yellow, or simply the area of the small semicircle. Now, if you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now, let's answer this question together. Our goal to this question is to find the area of this small semicircle. Therefore, if we get the length of the radius of this small semicircle, then we're done. Now, to answer this question, what we're going to do is to consider the center of this big semicircle. Now, since the length of the diameter of this semicircle measures 5 plus 4 plus 2, or simply 11 units, therefore we can say that the length of the diameter must be 11 units. Thus, the length of the radius of this big semicircle must be 5.5, or simply 11 over 2. It follows that this 4 is break into 0.5 and 3.5. So we have 5 plus 0.5, we have 5.5, and 3.5 plus 2 will give us again 5.5. Next, after considering the center of this big semicircle, what we're going to do is to consider the center of the small semicircle. And then what we're going to do is to connect them. Now at this point, we will use some concept. So the concept of perpendicular bisector. The perpendicular bisector of a chord passes through the center of a circle. Now take a look at the diameter of this small semicircle. This is also a chord of this big semicircle. Now notice that this radius is passed through the center of this big semicircle. And also, it divides this chord into two equal parts because this point is the center of this semicircle. It follows that this radius is a perpendicular bisector, or simply, this is perpendicular to its diameter. Now at this point, let R be the radius of this small semicircle. If this is R, this is also R. And the distance between these two centers, let's call this as X. Therefore, this part, the remaining segment, must be R minus X. Now at this point, we will use one theorem, which is the power theorem. Specifically, the chord-chord power theorem. So it says that if two chords of a circle intersect, then the product of the measures of the parts of one chord is equal to the product of the measures of the parts of the other chord. Given this figure, we can say that A times B must be equal to C times D. Now, to use this theorem, what we're going to do is to complete this yellow circle. And then, let's extend this radius. So we know that the length of this part, this segment, is also R, because we know it is the radius of this yellow circle. And now, using the chord-chord power theorem, we have R plus X times R minus X equals 0.5 times 3.5. Again, we have R plus X times R minus X, the small segment, equals 0.5 times 3.5. Now simplify, the left-hand side of our equation becomes R squared minus X squared, and the right-hand side, we have 0.5 times 3.5 and will give us 1.75. Now let's go back to our previous figure. Now at this point, from the center of the big semicircle, let's draw a radius directly to the endpoint of the diameter of this yellow circle. So now, this is also the radius of this big semicircle, and we know this is equal to 5.5. Now, since we have a right triangle right here, we can use the Pythagorean Theorem. So using Pythagorean Theorem, we know we have a squared plus b squared equals c squared. So we have r squared plus x squared equals 5.5 squared. 5.5 squared will give us 30.25. Now, don't forget our goal. Our goal is to get the value of r. So what we're going to do is to add these two equations. If we do that, we cancel out x squared. Therefore, we have 2r squared equals 1.75 plus 30.25 will give us 32. Now, divide both sides by 2 will give us r squared equals 16. Get the square root on both sides, and we get square root of r squared equals square root of 16. Since we want the length of the radius of this small semicircle, therefore we need to consider the positive value for r. Thus, the length of the radius must be equal to 4. Now we know that the length of the radius is 4. Now, it is easy to find the area of the semicircle because the area of the semicircle is given by the formula 1/2 times pi r squared. Now, we know the value of r, which is equal to 4. Now, 4 squared will give us 16. 1/2 times 16 will give us 8. Therefore, the area of the region shaded in yellow, or simply the area of this small semicircle, is simply 8 pi square units. And as always, we are done.